So today we're looking at LeetCode 42, trapping rainwater. It says given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. So this has the array 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1, which corresponds to these black squares. And then there's 6 units of rainwater being trapped, which corresponds to these blue squares. 1, 2, 3, 4, 5, 6. So here's the input, there's the output. Let's go ahead and dive into it. So for the trapping rainwater, we need to consider a couple of things. So if we are considering a height map like this, where it's like 1, 0, 1, like the simplest thing possible, where will the water go here? It'll be a height of 1. But why is that? Well, there's like this left edge and there's this right edge, and the water can only go in the middle here up to a height of 1. But like, what if this were height of 2? Would that matter? Well, in this case, our formula would need to change, because if the water fills up this area here, like it's raining and it's filling up and it's filling up and it's filling up, and then it keeps raining. We've got 1 unit of water here and it keeps raining. What's going to happen? This water is going to flow over this edge here. Okay. And if we had another spot here of height 1, that water is still going to flow over that edge. If we had another thing here of height 1, that water is still going to flow over that edge. But if we had something here of height, let's just say like, if we had something here of height 3, that water is not going to fill over that edge. Now what's going to happen? That water is going to start going over here, and it's going to collect in this whole area right here until it gets up to this point where it's height 2. And then what's going to happen? It's going to flow over this edge. And so that's why we do minimum of left edge and right edge. And so for the left edge in this example, we have 3, 1, 1, 0, and 2. We need to calculate the left edge. So the way we can do that is, I'll put this for the left edge. Well, we start here. And we say, okay, what is the tallest thing we've seen thus far? We haven't seen anything thus far, right? We can't look at the previous item in this left edge array because there are 0 elements here. We're on the 0th index. So the tallest thing we've seen thus far is the spot we're at, which is 3. And then we're looking here, the index 1 in the array. And we say, what is the tallest thing we've seen thus far? Well, tallest thing we've seen thus far is the 3, right? Because 3 is greater than 1. And then we're looking here, and we're like, what's the tallest thing we've seen thus far? 3. And then here, 3. And then here. Well, the previous item in the left edge array is 3, and this is 0. 3 is greater than 0, so still 3. Here, well, still 3. 3 is greater than 2. So that's the left edge array. And then for the right edge array, and so what's important to note is we went this way when we built up the left edge array. For the right edge array, we're going to go this way. And so we're starting here at the last element, which is 2. And so there is no previous thing to the right here. We're already in the last spot of this array. So we just use that value 2. And then here it's 0. When we're looking at this spot right here, the second to last spot, the height of it is 0. And the previous item in the right edge array, which is the item after this index, is 2. So it's 2. Right, because we're going this way. So when we want to look at the previous thing we have to go to the right, or +1. So it's what comes after in the array is actually the previous thing we looked at because we're going in reverse order. And then here it's 1. So still the greatest is 2. It's 1, so the greatest is 2. And then here it's actually 3. And then for the water, we look at the minimum of these things minus the height here, right? So the minimum of the left and right edge would be 3. But the height of the water here is not 3, it's 0, right? So we need to subtract off the height here, which is 3, which then gives us 0. So we need to modify our formula here. We say minus whatever's in the map at that index. And then I'll go ahead and fill this in. So this is the left edge for some given index, and the right edge for some given index. And this gives us the water at some given index. So if we want to know how much water is at spot 0, it's the minimum of 3 and 3, which is 3, minus what's in the map at the 0th index, which is 3, it gives us 0. And then here, the minimum of 3 and 2 is 2, minus the height of what is at that spot, which is 1, will give us 1, which corresponds to the amount of water here in this spot, 1. Likewise, 1, 1. Then here, the minimum of 3 and 2 is still 2, but when we subtract the height of the ground, which is at 0, 2 minus 0 gives us 2. That gives us 2. So we have 2 units of water here. And then here we can just visually see that there's 0, but the way we mathematically do that is we compare 3 and 2. The minimum of those two things is 2, and then subtract the height of the ground at that spot, which is 2, gives us 0. Okay, so we need to do 2 passes through the map. One from right to left, and then the other from left to right. So we're going to have const L equals some array, and const R equals some array. And we're going to do for let I from 0 up to map.length, non-inclusive, and we're going to build up the left array here, left edge array, and then likewise we're going to have another pass that's going from right to left. So we're going to start out at map.length -1 and go while I is greater or equal to 0. So count all the way down to 0. And this one's going to be I minus minus. And we're going to build up the right edge array. And then we're going to do another pass here. And we're going to do the math.min of the left edge and the right edge minus the ground elevation. So what we're saying is the largest thing to the left and the largest thing to the right are the things that bound the maximum amount of water. And out of those, the water can only go up to the lowest one, and then it'll start overflowing over either the left edge or the right edge. And then the water is obviously only going to start filling up at whatever the ground is at. So I'll have some variable w to track the amount of water that gets returned at the end. And then for this left edge here, what we need to do is, if we're at index 0, there's nothing further to the left, so we can only consider what's at map of I. Oops. What's at map of I, and that's if I is at 0. Otherwise, it's the largest thing we've seen up to this point, or what's at map of I. And so the largest thing we've seen up to this point would be whatever the previous item is in the left edge array, And then for the right edge array, in this case, if we're all the way on the right, it's the first iteration of this loop. I is going to be map.length minus 1. And so in that case, we want to just look at the height at that point, and that's the tallest thing. Otherwise, we do math.max of map I, and the previous item in the right edge array, which is going to be at our I plus 1, because we're going in the other direction from before. So we'll submit that. And that is how you do the trapping rainwater on LeetCode using JavaScript. Thank you.